Imagine everything in the universe squeezed into a space smaller than a grain of sand. Unimaginably dense and hot, this tiny speck contained all the matter and energy that would ever exist. Then about 13.8 billion years ago, it happened. The Big Bang. The universe exploded into existence, not with a sound but with an unimaginable expansion of space and time itself. It was like a cosmic firework display, but on a scale beyond comprehension. From that moment, the universe began to cool and expand, setting the stage for the cosmos we know today. In the first few fractions of a second, the universe was a chaotic soup of elementary particles. As it expanded and cooled, these particles began to combine, forming the first protons and neutrons. This early universe was a hot, dense, and energetic place, a far cry from the vast and relatively empty cosmos we observe today. But even in its infancy, the universe was already on the move, expanding outward and setting the stage for the formation of stars, galaxies, and planets. The Big Bang was just the beginning. The universe's incredible journey had only just begun. The universe is not static, it's like a giant loaf of raisin bread dough rising in the oven. As the dough bakes, it expands in all directions, and the raisins within it move further apart. Think of the raisins as galaxies. The dough represents the fabric of space-time itself. As the universe expands, the space between galaxies increases, pushing them away from each other. Imagine drawing dots on a balloon and then inflating it. The dots, like galaxies, would move apart as the balloon expands, even though the dots themselves aren't moving. That's the key to understanding the expanding universe. This expansion doesn't mean we are at the center of the universe. Every point in the universe is moving away from every other point. It's as if space itself is stretching, carrying the galaxies along for the ride. In the 1920s, Edwin Hubble made a groundbreaking discovery. Using the powerful Hooker telescope in California, he observed distant galaxies and noticed something peculiar. He found that the light from these galaxies was stretched, shifting towards the red end of the spectrum. This phenomenon, known as redshift, indicated that the galaxies were moving away from us. Hubble's observations provided the first concrete evidence that the universe was not static, as previously believed, but was indeed expanding. He discovered that the farther a galaxy is from us, the faster it appears to be moving away. This relationship, known as Hubble's law, revolutionized our understanding of the universe and its evolution. Hubble's observations were like a paradigm shift in our cosmic understanding. They opened up a new era of cosmological exploration, and his legacy continues to inspire astronomers today as they probe the depths of the expanding universe. Section 4, Cosmic Whisper Echoes of the Big Bang. If we could travel back in time to the early universe, we'd find ourselves immersed in a sea of intense heat and radiation. This afterglow of the Big Bang, now cooled to a frigid -2.7 Kelvin, still permeates all of space. We call it the cosmic microwave background, or CMB radiation. Discovered in 1964, the CMB is like a faint whisper from the universe's infancy, a baby picture of the cosmos. It provides us with a snapshot of the universe as it was just 380,000 years after the Big Bang. The CMB is incredibly uniform, with only tiny fluctuations in temperature. These fluctuations, however, are incredibly important. They represent the seeds of the large-scale structures we observe in the universe today, like galaxies and clusters of galaxies. By studying the CMB, cosmologists can learn about the universe's early conditions, its composition, and its evolution. It is a cosmic time capsule that continues to reveal secrets about our universe's birth and growth. Section 5. The Mystery of Dark Energy, the universe's accelerator pedal. In the late 1990s, astronomers made a startling discovery. The universe's expansion wasn't just continuing, it was accelerating. This unexpected finding suggested that a mysterious force dubbed dark energy was at play, counteracting gravity and pushing the universe apart at an ever-increasing rate. We know very little about dark energy. It makes up roughly 68% of the universe's total energy density, yet its nature remains one of the biggest mysteries in modern science. Some theories suggest that dark energy is a property of space itself, a sort of cosmological constant that drives the accelerating expansion. Others propose that our understanding of gravity is incomplete, and that on cosmic scales, gravity behaves differently than we currently understand. Unraveling the mystery of dark energy is crucial to understanding the fate of the universe.